Hi, my name's Gabe. For this problem, we're given two planes, and we're asked to find the angle of intersection between the two planes, and then we're going to write this line of intersection as a set of parametric equations. So let's go ahead and get started by trying to find the angle of intersection between these two planes. So we know that the cosine of this angle of intersection, we'll call it theta, is equal to the absolute value of the dot product of n1 with n2, where n1 is a vector which is normal to our first plane, and n2 is a vector which is normal to our second plane, divided by the magnitude of n1 times the magnitude of n2. So let's actually find our n1 and n2 before we get started trying to find this angle. So we can look at each of our planes, and we see that they're already in the general form. So just by looking at our first plane, we can write n1 is equal to the vector 1, 1, negative 2. And looking at our second plane, our vector n2 is equal to 2, negative 1, 3. So now we can go ahead, we can find this dot product, and we can find the magnitude of n1 and the magnitude of n2. So n1 dotted with n2 is going to be equal to, well, 1 times 2, which is 2, plus 1 times negative 1, which is negative 1, plus negative 2 times 3, which is negative 6. So we have the dot product of n1 with n2 is equal to negative 5. Now let's go ahead and let's find the magnitude of n1. So this is going to be equal to the square root of 1 squared plus 1 squared plus negative 2 squared, which is going to be equal to the square root of 6. And now let's go ahead and let's find the magnitude of n2. So this is going to be the square root of 2 squared plus negative 1 squared plus 3 squared. So this is going to be the square root of 14. So now we have all of this found, we can go ahead now and write down the cosine of our angle theta and what that's equal to. So we'll have cosine of our angle theta is equal to the absolute value of n1 dotted with n2. So in this case is going to be the absolute value of negative 5, which is 5. And it's going to be divided by the square root of 6 times the square root of 14. Now we could simplify this a little bit here, but we don't have to, since what we're looking for is this angle theta. So we can use the inverse trigonometric properties to write our angle theta as arc cosine or cosine inverse of 5 divided by the square root of 6 times the square root of 14. And here we can use a calculator to actually approximate our angle. So what we see is this angle is approximately 56.94 degrees. Now for the next part of the problem, we're asked to find the parametric equations for the line of intersection of our two planes. So let's go ahead and let's just write down the two equations for our two planes. So this is x plus y minus 2z equals 0. And our second plane is given by 2x minus y plus 3z equals 0. So now our goal here is to rewrite two of these variables in terms of the other one. So what I'm seeing right here is we can actually add these two equations together in order to cancel these y's. So what that'll give us is 3x plus z is equal to 0. So here we can either solve for x or solve for z. It might be a little easier to solve for z, so let's go ahead and do that. So we can do that by subtracting 3x from both sides of the equation. So we have z is equal to negative 3x. Now, we can substitute this back into either one of our equations to solve for y in terms of x. So let's go back to the first equation. We have x plus y minus 2z. Well, we're going to replace z with negative 3x. And this is equal to 0. So what this equation becomes is x plus y plus 6x is equal to 0. Well, this simplifies to 7x plus y equals 0. And here we can actually go ahead and we can solve for y by subtracting 7x from both sides of the equation. So y is equal to negative 7x. So what we'll want to notice here is we have y solved for in terms of x, and we have z solved for in terms of x. So what we're going to do here is we can actually say, well, let's let x equal our parameter t, and then from here, well, what we end up with is we end up with two more equations. Y then is equal to negative 7 times t, and at the same time, z is equal to negative 3 times t. So what we end up with here is we end up with a set of parametric equations representing the line of intersection between these two planes. Thank you.